Next up, scientific notation. Scientists often have to deal with very large or very small numbers. And writing 0.00000000872 gets kind of old. So we have a system that will convey that information a little more succinctly without all of the zeros. And it's called scientific notation. And numbers in scientific notations look something like this. C is often referred to as the coefficient or the decimal part. Its real name is mantissa. And in proper scientific notation, it is a value that is greater than or equal to 1 and less than 10. And n up here is called the exponent, and it's going to be a positive or a negative integer. And I should note that the mantissa C could also be a positive or negative number, but the magnitude is going to be between 1 and 10. Now, to convert from a decimal number, you figure out the mantissa by moving the decimal point to the immediate right of the leftmost zero, and I will give you examples of all of these. And you get the value for the integer by how many places you had to move to get that done. And the sign of that integer you get by looking at whether you had to move the decimal point left or right to do that. If it's moved to the left, it's positive, so that's for big numbers. And if you moved it to the right, it's negative, and that's for very small numbers, numbers that are much, much less than 1. So here are a couple of examples. So the number 3,245, not a huge number, but it's a good place to start. So the decimal point would actually be here. And the idea is you want to move it so that to the right of the first non-zero decimal. So in this case, you're going to move it from here, and you're going to move it 1, 2, 3 positions. So we moved it to the left. We moved it 3 spots. So now the mantissa, the coefficient, becomes 3.245 times 10 to the positive third. Now, usually if the exponent is a positive number, you don't write the positive sign, but I'm doing it here just for clarity. Now, this next example here is an example of a number that is very small, that would be tedious to write repeatedly. And so again, we're moving the decimal so that it is immediately to the right of the first non-zero digit. So we would start, so this way, we're going to be moving the decimal to the right, and it's going to be 1, 2, 3, 4, 5, 6 places. So now in this case, our mantissa is going to be 3.245 times 10 to the negative 6. Now I will leave it to you on your own to make sure you can replicate the other ones as well. Let's do one more. So this very large number here, let's say this would be 3,245,000,000, bunch of zeros. So here we're looking at moving the decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the left. So it's going to be 3.245 times 10 to the positive 9th. And make sure you get to the other ones, or you can replicate those. So if you can do all of these on your own, you're in pretty good shape. Now, the next thing we need to do is learn how to multiply, how to mathematically manipulate numbers in scientific notation. Basically, we're going to talk about multiplication, division, addition, subtraction, and raising powers. Now, I'm going to do 2 things here. I want us to go over and show you how to actually do this with the calculator that does not have scientific notation, and also go through a couple of examples so you can make sure that you can use your calculator with scientific notation. Now again, I want you to be able to use your calculators. All right, so let's look at that. Now, the old school way of doing this is if you're multiplying numbers in scientific notation, you multiply the coefficients, and then you simply add the exponents together. So this 4.0 times 10 to the 6th times 1.5 times 10 to the negative 3rd. The answer would be 4 times 1.5. Actually, before I do that, I'll give you another example here for division. And so the rule here is that if you're doing division, you simply divide the coefficients and you are subtracting the exponents. So this is 4 times 10 to the 6th times 1.5 times 10 to the negative 3rd. And so this answer is going to be whatever 4 times 1.5 is, and that is 6. And then you simply add it, and 6 plus negative 3 is positive 3. So the answer here is 6 times 10 to the negative 3. Now, I would encourage you to hit pause, bust out your calculator, and try and multiply those two numbers and make sure you get that answer. Now let's do the same thing for the division example. So for the coefficient, we're dividing 6 by 2. That's going to give us 3. And we are subtracting the coefficients. Now, did you guess 3 times 10 to the positive 15th? Now, there's a couple of things. If you're doing it without the calculator, remember, 8 minus negative 7 gives us positive 15. Now, I also want you to stop and do this in your calculator. Now, if you get the 3 right, but not the 10 to the 15th, there is a very good chance that you have, you're just not using your calculator the correct way. This is a really common mistake that I found with students in this class. So I'm going to take a little break here, talk about calculators. So here's a picture of the keyboard on a TI-30XA, which is a pretty common scientific calculator go around. The idea is pretty much the same thing. The big irony is that when you are entering numbers in scientific notation into a calculator, they do not look like they are written down. Namely, and I'm blowing up the keyboard here, you do not want to use the multiplication key for the times 10 part, nor do you want to use the 10 to the x key. So it's right here. I've shown it blocked out here. What you actually want to use, and this is a little different for each manufacturer, but it's going to be something like this EE key. And sometimes, even on some TI models, it's a second function. And when you do this, you should not have to do the multiplication sign within the number or that 10 to the whatever power. This link right here, and if it's not live in the video, I'll put a link to it on Learn for this unit, is it's someone actually going through an example how to do this properly. If you do that and you're still getting the wrong answers, please contact me. We'll set up a Zoom meeting. It is critical that you learn to do this the proper way, because there are some times where what's happening is the calculator is not performing the operation that you think it is, and therefore it could give you a completely different answer. This happens a lot, and I like to nip it in the bud, as soon as possible. So take a look at that video. If you cannot adapt it to your calculator, let me know. We will fix it. All right, back to the rules. So the other thing that you commonly have to do for scientific notation is to raise a power. All right, so my examples here. So if you're raising a power, which is what this example does right here, the idea is that you raise both the coefficient, the mantissa, the coefficient, and the root to that power. And if you are taking a root, it's the exact opposite. Again, do it both to the operation to both the mantissa and the exponent. And so, for example, here, you're looking at, this is going to expand out to be 2 to the third power. And the way that you take an exponent, raise it to a power, is you multiply it. So this is going to end up, so 2 to the third power is just 2 times 2 times 2 is 8. And negative 2 times negative 3 gives you a power of 10 to the negative 6. So the cube of 2 times 10 to the negative second is 8 times 10 to the negative 6. Again, make sure that you do this and get that same answer with your calculator. They're all a little different, so let's just make sure we're on the same page here. And finally, to take the root, so this sign here is for a square root. And so this operation would be equal to the square root of 9 times, and then here we are dividing. So to raise that exponent to a particular power, or to take that particular root, divide by it. So we get the square root of 9, which is 3, and then times 10 to the exponent here is 4 divided by 2, or just 2. Again, for both of these, make sure that you, with your calculator, get that same answer. And again, if not, we can zoom in and I can look at your calculator. We can make that work. All right, so that's it for the fine points of scientific notation.